Okay, so here in front of me I have all of the equipment we're going to need to make our own voltage divider. I've got the Arduino Uno, I have our breadboard, two resistors of differing resistances, and we'll get to what those are in a minute. And then also 3 wires. I picked black, red, and yellow. I always have black and red, or almost always in my circuits because they represent power and ground, which I almost always need. And then the yellow is going to be for a signal that we're going to take later, which we'll see. We'll see where that goes. The 2 resistors I have here that I'm using are the 10,000 ohm resistor, which is the one with the orange band, and the 4.7 thousand ohm resistor, which is the red band. Now, I plan on having the red banded resistor first, and then the orange banded resistor second. So the question is, how much voltage do I expect to get out of my circuit based on what we just went over with the V in, V out, and the different ratio of resistances? That's a good question. One that I cannot answer without a calculator. So we have a total resistance 10,000 plus 4,700. All right, so that's our total resistance there. Now, what we are doing is we're putting the 4.7 thousand ohm resistor in the position of R1 and the 10,000 ohm resistor in the position of R2. So to figure out what our output voltage should be, I'm going to need to take 10,000, which is R2, and divide it by our total resistance. All right, so this number is the amount of the input voltage we're getting. So I'm getting about 68% of the output voltage. So what I want to do is I want to figure out how much of 5 volts is that. And it looks like it's about 3.4 volts. So what I should expect to get out of V out is 3.4 volts. It's going to take us to some time to see if that's actually what we're getting. First, we're going to need to actually build the circuit out. So I've got my Uno. I actually don't quite need that yet. First things first, I'll get my 2 resistors. Now, like I said, my red banded resistor, the 4.7 thousand ohm resistor, is going to go in the position of R1. So I'll need to make sure to remember that power is getting put at the top of R1. And then I have my 10,000 ohm resistor in the position of R2. No, it's not getting in there. There we go. All right. So importantly, I hope that it's visible here, but the 2 resistors share a row right here. So one leg of each resistor is on a shared row. So like I said, this is going to be R1, so I want to make sure it gets power on this end. And then this is R2, so it gets ground on this end. And I should probably bring my Uno into the mix now and make sure that I'm plugging these in the correct place. So I have 2 ground pins that I can choose. And then I have 1 5-volt pin right here. All right. Now, lastly, I want to pull the signal from V out because I want to actually measure that and see if I'm correct in thinking that I'll get 3.4 volts. So what I'm going to do is take the position where V out is in between the 2 resistors after the voltage has been split, and I'm going to take that wire and I'm going to put it here in A0. Which is going to allow me to read from the Arduino what the voltage there is. So this is all we need to do to set up our circuit. And from here, it's just a matter of figuring out how we can code this so that we can actually get a voltage from here. So we can actually read that voltage and hopefully confirm what we think we know. So let's get to it. All right, so here I'm in Ardu block, and let's try and remember what our goal is here, what we're trying to accomplish with this code. We just want to be able to confirm that the voltage out is what we expect it to be. So in this case, it's 3.4. So we need to find some way to get the Arduino to tell us what the number is for voltage. So there is a pretty simple way to do that. In the communications tab here, we'll find the serial print ln block. And we have a message here. You can put whatever you want in the message. You can put, crazy stuff. I have students do that all the time. I'm just going to put something that in context makes sense for us. So I'm just going to say the voltage is, and hopefully I'll get some number back out here. However, I want it to read a specific value. I want it to read the value in between those two resistors. Remember, we put that wire there, and we attached that wire to the Arduino on A0, so pin A0. So I have an analog pin numbered 0, and I want it to read specifically this value. Whatever number this is giving us, I want this to be what's printed out. Unfortunately, I can't place this here. So I have to go back into communications. I have to look for the glue blocks. And notice you have two glue blocks you can choose. I'm going to choose the one where it looks like the analog pin will fit into it. This more jagged one rather than the rounded concave one. And typically speaking, when something is jaggedly faced like this, it means it expects a number rather than just a digital value like high or low. So this glue is saying I expect some number, which hopefully analog pin 0 will be able to give us. So this is all we need to do. We're just going to print this we're going to upload this. Hopefully it prints back to us a number which we recognize as the voltage. First and foremost, I need to make sure that I have all of the correct options. So port, I need to select a port, and then I need to make sure that the board, because I'm using Arduino Uno. All right, so that's all in order. We're going to go ahead and try uploading. I don't need to save that. All right. Come on. There we go. No errors. Love it. Great. All right. So next, I'm going to click here on Serial Monitor. And because I've used some of those blocks, I get the message that I intended printing out here. I will say, however, if we look at those numbers, 646, 645, mostly 646. That is not what I expected. That is not a number between 5 volts and 0 volts, which is a bit of a problem for us. So let's try and figure out what this number means. Why is it giving us 640 something, rather than just giving us a number between 5 and 0? Hopefully 3.4 like we expect.